Okay, it's going.
Awesome.
All right.
Okay, so the first one, lesson 16. Pick from the list of graphs below. Which graphs can you use to describe categorical data? And I said pie charts and bar charts.
Yes. And when given a sample, what is the formula to compute p hat, and explain what each variable stands for in your formula? And I said p hat equals x divided by n, and it's sample proportion equals response divided by sample.
Awesome. Okay. What is the mean of the sampling distribution of the samples proportion p hat? State this answer in words, not just simple. And I said it is the population proportion.
Yeah. What is the standard deviation of the sampling distribution of the samples proportion? P hat. So say your answer in symbols will include what symbols mean. Standard deviation for a p hat equals the square root of p times 1 minus p divided by n. So n is the total sample size and p is the true population proportion.
Awesome. What is the difference between categorical and quantitative data? What are a couple of examples of categorical data? Quantitative data has to do with the amount of something, and categorical doesn't have to do with numbers, but instead has to do with the different categories. I totally did not answer the second half, but I guess examples of categorical data would be like the type of toothpaste someone uses, or yeah,
exactly. Candy bars.
Yeah,
like that. All right, open the file class survey using the file format for your class. Create a pie chart for the class rank, label it and post it here, which I did.
Awesome. Next, create a bar graph, the class rank, label it, post it here. That too.
And then it says show at least 5 ways, graph the numerical statistics to describe the data above. So I could not get my SPS to do the whole sort it by weight class. It didn't give me that to do the rank, and I just didn't want to do it by hand. But what I would have done was taken like how many freshmen there are out of the total number, you know, so and how many sophomore there were out of the total number.
Yeah, that's what I did. I just guessed with my bar graph the numbers that it would have been.
Right.
So I tried to do it with SPSS, but it wouldn't let me just do those numbers.
Yeah.
So I just guessed them.
So then how did you
I compared.
Do the rest of it without having actual numbers?
I didn't. You mean the rest of number 9?
Number 9. Yeah, never mind. The numbers are there. Never mind.
Yeah, the number is a different one. But yeah, I couldn't figure out how to do it on SPSS for that one, so I just guessed the count. So like for freshmen, I said there was 8. Just looking at my bar graph.
That must be
sophomore.
Wanted us to do.
Yeah.
From the,
I guess. I don't know. Okay, so 7% is the true unknown percent of the population that do not have traditional phones and instead rely on cell phones. 7% is P. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, 8%, in the survey use only cell phones? What is the mean and standard deviation of the sampling distribution based on 750 telephone users? So the mean is 7%. I was not sure how to find standard deviation, but on the answer sheet it said 0.0093.
Right, so standard deviation is P times 1 minus P divided by N.
Okay.
The square root of all that. Square root of P times 1 minus P divided by N.
Okay.
Right?
Okay.
And then he had a spreadsheet that we can just plug the numbers in. So So P is, what's P?
0.07.
0.07. And N is 7 or no 60.
Yeah.
What was the answer?
Are you talking about for B? Are you doing B right now?
Standard deviation.
Oh, standard deviation, it was 0.0093.
So that's not right. So 0.009, yeah.
Okay, awesome.
It just gives you 2 places, so 0.009.
Okay. Okay. Wait, did you just say Z? I mean the Z-score, or were you just saying the standard deviation?
Right, is 0.09. And so then the Z-score would be,
I did 0.08 minus 0.07 divided by, what did I divide by? I don't know what I divided it by. Sheesh, what did I do?
so we need to,
But I got the answer.
we have to figure out the X divided by N, which is 60 out of 750, is that right?
No, I did 0.08 minus 0.07 divided by some number. I don't remember what number I did, and I got the same answer that it was on the, except for like a couple of, I did it by standard deviation divided by 0.0093. I got 1.075, so I was just off by 3.
Okay. This, and I Excel this weird stuff here. Oh, where'd it go? So what did you get for Z-score?
1.075.
Yeah, I got 1.073, but
Okay.
pretty close.
Okay.
So what is the
And then,
go ahead.
oh, you go ahead.
What is probably that
You're good.
more than 60% in the survey use only cell phones?
I used a normal probability applet for this and put 1.073 into the Z-score. And then the area ended up being 0.1416.
Ah, stop. This did that. No. Okay, I just totally messed this up. You got what?
0.1416.
Yeah.
Awesome.
Okay.
Okay. So we can do the group quiz now.
Yeah, I just messed this up and I cannot get out of it. Okay, good. Okay.
Okay. Are you ready?
not quite. I had my
Okay.
my Excel spreadsheet was.
Okay, no worries.
Okay, now I'm ready.
Okay. In a pie chart, why are the slices sectors different sizes? Let's see. The size of each slice is random. The size of each slice is determined by the number of categories. Each slice represents a category, and the area of each slice represents a proportion of the total occupied by the category. And pie charts are more visually appealing when the slices are different sizes. I think each slice represents a category.
Yeah. Because for how are bar charts and pyramid charts related? Pyramid charts are constructed from tossing a coin several times. They're identical. The only difference between a bar chart and a Pareto chart is that bars in a Pareto chart are ordered largest to smallest, going from left to right. So it's that last one. Largest to smallest.
And we conclude that, yeah, thanks. We conclude that p hat is normally distributed if np is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Is p the true proportion or the sample proportion? The true proportion, right?
Right. What is n? The number of successes, the number of candidates in an election, the sample size. So it's the sample size.
If p equals 1/4, what is the smallest n that satisfies the requirement? Would it be 4?
So no. So basically you have to plug, you have to solve for n in that formula up above, and p is greater than or equal to 10.
Oh, right.
And solve for n and see what the smallest is that you possibly can have, the smallest that you can have. So you put in the 1/4 for p.
Oh, okay.
So if you do n is n times 1/4 is greater than or equal to 10. Then multiply both sides by 1/4, you get n is greater than or equal to 40.
Okay.
Then if you do it the other way, n times 1 minus 1/4 is greater than or equal to 10. Then you end up with n times 3/4 is greater than or equal to 10. So then you have to multiply both sides by 3/4, which ends up n is greater than or equal to 40 over 3. So then if you plug in, if you can plug in your 14 times 1/4, if it's greater than or equal to 10, on both sides you could use 14, but it's not greater than or equal to 10. With that first formula, MP is greater than 10, so you have to use 40.
Okay. Okay. Was it my turn to read or your turn?
I think it's your turn. My turn. Using the following information to answer the next two questions, suppose n equals 24 and p equals 0.4. What is the mean of p hat? And the answer to the nearest 10th. And I think I used a formula for that. Oh no, it's the mean is the same as the
Yeah, 0.4, right?
or right.
Okay, what is the standard deviation of p hat round to the nearest 10th?
Well, it's a formula that I have. He has a spreadsheet for it, so we can plug
Yeah.
those in.
Awesome.
P is 0.4. And 24. So the standard deviation is 0.100.
We can just do 0.1 because it's round to the nearest 10th.
Oh, okay. Good. Use the following information to answer the next 4 questions. Brittany's batting average is .300. We want to determine the probability she will get more than 35 hits in her next 100 at bats. N equals 100 and P equals 0.3.
And to the 2 decimal places, so 0.30, right? For the answer for what is p hat, right? Or is that not? I was thinking this was the same as the last. Oh yeah, it would be, right? Or the mean. I was asking what p hat is, not the mean of it.
P hat is the 35 divided by 100.
Okay. 0.035. No, not 0.035, 0.35.
0.35, right?
Yeah, sorry, I said 0.035, but I meant 0.35.
So 0.35. 35 divided by 100 is 0.35.
What is the standard deviation of p hat round to 3 decimal places?
Okay, so we have E is 0.3, N is 100, so the standard deviation is 0.046. What is the z-score? So p hat was 0.35, right? Yeah, so the z-score is 1.091.
Okay. What is the probability Brittany gets at least 35 hits in her next 100 bats? Round to 3 decimal places.
So at least we plug that into the probability app. Okay. 138.
0.138. How do you find that?
I'll put it on the probability app. You put the z-score.
Oh, okay.
091, and it's above.
Right. Put 138. Perfect. Okay.
Whose turn is it?
I think it's you.
Use the following information for the next 3 questions. if the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election in less than 50% of the votes. What is the standard deviation of P? Okay, so standard deviation is 0.52 P, and 2,000 is N. So the standard deviation is, standard deviation is 0.011.
And then what z-score would you use? Round to 3 decimal places. So,
P-hat was 0.5. So the z-score was a negative 1.790.
So losing the election, less than 50%, 0.036 or 0.037. Is that what you thought?
Yes.
Okay. Is it you? I think it's your turn to read.
That was the last one, right? What is the probability of the survey? Wait, what did you just say?
Yeah, it was your turn to read. Number 16.
No, number 15, the z-score.
I think I got 0.037.
No, the z-score is negative 1.790.
Oh, negative 1.790. I was figuring out the let's see, what was I trying to figure out? I was doing something totally different. Okay.
No, what you figured out is the next answer. The probability 0.037.
Okay, perfect.
The probability is 0.037.
Okay. Okay. Let's see. Awesome, we got them all right.
Nice.
Okay. Okay, so we have that big project.
Right.
Let me see. So do we all turn this one thing in, the design and study, or is it just one of us? Do you know?
I think everybody does. Let me look at it again. Where did I put it? Maybe I didn't actually save it yet.
Oh, wait, actually, so it says, please write below which group members will be the main writers for each step of the project. The main writer will be the one to collect everyone's ideas and suggestions. They're then responsible to send out the document for feedback and apply the feedback to the document before submitting it.
Oh.
But I don't know if that means everyone submits it, because they send out for feedback and then apply the feedback and then submit it. So I think only one person submits it.
Okay.
So maybe what we could do now, because Bryce isn't here, so I don't know, we could like send him an email and say you really need to be here Thursday so we can do this.
Yeah.
Maybe right now we can just write down the main writers for each of these studies, just assign ourselves.
Yeah.
You know what I mean?
Yeah.
And then do the rest of this with him on Thursday.
Yeah. Maybe come up with some ideas. And I don't mind keeping track of this and
Okay.
typing it up and stuff.
Okay. Cool. Yeah, so I think one person submits it, but I'm not sure.
I'll say down here, where did I just read this? After you've designated which members of your group will be in charge of each step above, ask your group leaders to submit this document with the names filled in above.
Oh, okay. So did you want to be the leader for this one?
Yeah, I can do it.
Okay. Okay, so maybe we can, maybe what we can actually be doing is emailing you like throughout the day, and tomorrow we can send an email to Bryce about it, kind of like when you sent, you just say, send me ideas. By Thursday, you can have some of that information already written in here, but then we can go through each of the questions,
Yeah.
you know.
Right. And what I can do is I can put this document actually into
Google Docs.
I can put it into BYU's Word through our BYU emails,
Okay.
and we can actually all have access to it. I can share it through that.
That'd be great.
And then,
That'd be good.
yeah, then we can all look at it at the same time and make
Okay.
changes to it as we want, actually.
Perfect. That's good.
So I'll do that.
Okay.
And
Perfect.
we'll share like with our Gmail addresses. I'll see if it will or not. Yeah, and then let's see if we can decide what. Yeah, because we basically have to come up with basically what we're going to do. We basically have to come up with our plan and get it all out by Saturday. So
yeah, well, right now maybe what we can do is talk about what we want it to be about, so that like we can start adding, you know.
Yeah.
We can start adding things to it. So I guess like here are some examples. Are there 1,000 chips in every bag of Chips Ahoy? Are brand A paper towels stronger than brand B? Is there a difference in the prices of books at a bookstore compared to those available online? Thank you. Are men or women more likely to walk on the grass if they're walking behind someone who walks on the grass? So, I mean, should make it kind of a fun one since we can decide.
I know, right? I know. I was like, we should like do something with M&Ms or something so we can eat them when we're done or something.
Well, we could do like, are there, let's see. Are there more red M&Ms? Like, is the proportion of red M&Ms larger in a bigger bag of M&Ms? You know what I mean? Or in a smaller bag or something, you know, something like that. I don't know.
Or we could compare all the bags of, like, pick a number of bags of M&Ms and compare the colors. Like,
yeah,
like we could each take so many bags of the regular size M&Ms and each count colors and see if if each bag
that's a good idea.
has the same amount of colors.
Yeah, or even like, yeah, that's a good idea. So we could,
like, if each of us did 5 bags each or something, so then we'd have 3 data sets.
Yeah, that's a good idea. So I guess our research question would be, we are trying to determine if each bag of regular sized M&Ms has the same amount of each color.
Right.
I guess that would be it. Okay, cool.
Like that, yeah.
Cool. Well, I think that then throughout the week or before Thursday, we can just be adding things in there. You know, we can tell Bryce to do the same thing. And then the ones that we haven't answered yet, we can just answer all together.
Right, yeah.
Cool. All
right, I'll see if I can.
Awesome. Well, then and if you can't do it on there, then you can always go through Google Docs and send us an invite there, and we can all go on there too.
Yeah, exactly. Okay.
Okay. Sounds good. Well,
All right.
I'll talk to you Thursday then.
Okay, great. Thanks.
Bye.
Bye.